resisted motion. An object is launched at some angle theta about horizontal. This x is horizontal. The magnitude of initial velocity is v0, and this is theta angle. And vertical coordinates I called y. The initial condition is as follows. At time t equals 0, v0x equal to v0 times cosine theta, and v0y equal to v0 times sine theta, and x equal to 0, and y equal to 0 at time t equals 0. The equation of motion is this. In x direction, I have I'm ax equal minus b vx, and this I called equation 1. And in y direction, I have I'm a y equal minus I'm g minus b v y. This is equation 2. So the equation is this. On the right side, it's force. This is force in x direction. So Fx equal to max. And this term is Fy. So Fy equal to may. So this is Newton's equation in x direction, and this also Newton's equation in y direction. And B is coefficient. This is the air resistance force, which is proportional to Vx. The negative sign indicates the resistance force is in opposite direction of velocity. In the y direction, I have gravity force, and I have air resistance force. The air resistance force in the y direction is in proportional to the negative of velocity in y direction. These are the two equations of motion for resisted motion. Now we try to solve this equation first, and then we solve this equation second. The plan this. From equation 1, we solve Vx as function of time. Vx as a function of time. Then after we solve Vx, we solve the position x as a function of time. Then from equation 2, we do the same thing. From equation 2, we solve Vy as a function of time, and position y as a function of time. Now we do this first. From equation 1, we solve Vx as function of time. So now we solve equation 1 first. From I'm ax equal minus b Vx and ax equal dvx dt. This is definition of acceleration, dvx dt. Therefore, we plug in this quantity into here, we get the following. So I'm dvx dt equal minus b Vx. Therefore, we have we move m to the right, so we move Vx to the left. So I have here 1 over Vx dvx equal minus b divided by m dt. Now, on the left side, we have only Vx. On the right side, we have coefficient and time. So we integral both sides. We have this. 1 over Vx dvx equal integral here b divided by m dt. So on the left side is ln log Vx equal minus b m and t plus an integral constant. C is integral constant. Therefore, Vx equal to e to the power minus b m t plus constant c. This one we called equation 3. Equation 3. Now, we have an integral constant. We need to determine the integral constant. So, if time equals 0, we have Vx equal V0x equal V0 cosine theta. This is our initial condition. If t equals 0, V0 x equal to V0 cosine theta. This is our initial condition. Now, therefore, this quantity we put on here, we have V0 cosine theta equal E minus B I'm time t equals 0 plus c. I plug in t equals 0 here, t equals 0, then Vx equals V0 cosine theta. Therefore, I have V0 cosine theta equal E to the power c. E to the power c. Now, therefore, equation 3, we have here Vx equal equation 3 become Vx equal E to the power minus B divided by M time t and time e to the power c equal E minus B I'm T and e to the power c equal to V0 cosine theta. So it's V0 cosine theta. i.e. Vx equal V0 cosine theta e to the power minus B M T. This equation I call equation 4. Equation 4. And I would like a box this equation. Now, we just finished Vx as function of time. That means our plan. Here's our plan. We solve Vx at function of time t. At next step, we need to find position x at function of time. But before do that, we want to find the physical meaning of this equation, this part. From this equation, we have here at time equal to 0, at time 0, Vx equal to V0 cosine theta. So t equals 0, e to the power 0 is 1, so Vx equal to V0 cosine theta. As time approaches infinite, this term e to the power negative b divided by m times infinite, e to the negative infinite, this term equals 0. 0 times V0 cosine theta, so Vs approaches 0. So Vs approaches 0. Now, this part is finished. The next objective is to find x as a function of time t. From this equation here, since Vx equal dx dt, we plug in this quantity in here. So we have dx dt equal V0 cosine theta e to the power minus b divided by m times t. Now, we move dt on the right side. So we have here dx equal V0 cosine theta e to the minus b divided by m t and dt. Now, integral both sides, we have here dx equal integral both sides V0 cosine theta e to the power minus b divided by m t then dt. So I integral both sides. Now on the left side, I have here x, then equal on the right side, I move this out, V0 cosine theta, the integral e to the power minus b m t dt. Now, next step, since this is dt, but e to the power, this argument is not t alone, we have negative b divided by m. So therefore, at here, I time minus sine minus 1 v0 cosine theta I'm divided by b, that e to the power negative b m t, that d negative b m t. Because this one quantity is not same as t, so I want to make sure the e to the power, this argument is the same as here. So I put minus here, I put b here, I put m on the bottom. So in the same time, negative here get positive. So I'm on here, I'm on bottom, so cancel out. So b cancel out. So this quantity on the right is on top, this quantity. So now I have this quantity is the same. So this one is the same as here. It's same. Now I can integral minus v0 cosine theta m divided by b, and this part is e to the power minus b divided by m t plus an integral constant. I call this equation as equation 5. Now, I have integral constant. I need to determine the integral constant c prime from the initial condition. The initial condition we have here, at time t equals 0, x equal to 0. This is our initial condition. So the initial condition is this. If t equal to 0, I must have x equal to 0. This is our initial condition. So this is the equation. So if I put t equal to 0, here, I must get x equal to 0. So therefore, I have here is 0 equal minus v0 cosine theta m divided by b e to the power minus b divided by m times 0 plus an integral constant. and e to the 0 is 1. So therefore I have here 0 equal minus v0 cosine theta I'm divided by b, e to the 0 is 1, so plus c prime. Therefore, my c prime, which is the integral constant, equal v0 cosine theta times m divided by b. Plug above c prime into equation 5, so plug above into equation 5. We have x equal v0 cosine theta I'm b minus v0 cosine theta times I'm divided by b times e to the power minus b divided by m t. And I can reorganize this equation as x equal v0 I'm divided by b cosine theta bracket 1 minus e to the power minus b m times t bracket. This equation I call equation 6. And this one, I box this equation. Here we find x as a function of time t. This is our plan here. Find x as a function of time t. And next step, we need to find vy as a function of time t and y as a function of time t. But before we do y condition, we need to find the physical meaning of x as a function of time t. At time equal to 0, x equal v0 times m divided by b times cosine theta times bracket 1 minus e to the power minus b divided by m times 0. So this term equals 0 bracket equal to v0 times m divided by b times cosine theta times bracket 1 minus e to the 0 is 1 bracket equal to 0. And this is the initial condition. As time approaches infinite, I have x approaches x equal v0 times m divided by b times cosine theta times bracket 1 minus e to the power minus b divided by m times infinite here. Now this equal v0 times m divided by b times cosine theta times bracket 1 minus e to the negative infinite equals 0. So I got v0 times m divided by b times cosine theta